I'd like to introduce our speaker for today's presentation, Igor Alcantara, Data Science and Education with IPC Global and Click. With that, I'd like to turn it over to our presenter. You can take it away from here.
All right. Thanks, Megan. Can you all hear me?
We can hear you perfectly.
All right. So, again, I am Igor Alcantara. I work for IPC Global as Director of Data Science Education. As Megan introduced me, also Click Community MVP, Click Ambassador for social media. I work with Click and this type of technology for plus 20 years. And I'll be your presenter today. And as Megan said, we'll have 3 questions for you today. So one at the beginning, one in the middle, one close to the end. And let's start with the first question before I start my presentation. So, so you'll see the poll showing up on your screen, and so feel free to answer that question. So now let's kind of start with the presentation, and I will present today's webinar. However, I am not presenting this alone. So because the things I'm presenting, sometimes I will play different roles. And so I decided, well, why not, instead of me presenting different roles, then I bring, some guest speakers so each one can, speak about their own role and how they use these technologies. So let me introduce you the guest speakers of today. So, which are the basically voices in my head. Look, jokes aside, we have the HR analyst as the person that will dig into the data. And it could be any analyst. We show in an HR use case today, but it could be any analyst, any business expert. It's the person that will work directly with the operations and use data analytics to have a more data-driven decision. And we're also talking about call center. So we have the call center rep or support agent rep. So that will be the person who get the problems, who get the cases, and then we investigate those cases. So it's a person with investigative mindset, and we find the right information for the clients. And then we have the person who's actually keeping everything running behind the scenes. So the system engineer sometimes could be a data scientist, but basically the person that's running everything and is making sure everything runs smoothly. So these are the 3 guest speakers. So when you see me wearing the screen hat, then I'm playing the analyst. The blackish, I think it's black hat, then I'm the call center rep. And when I'm using that beautiful, that's my favorite one, brown hat, then I'm the engineer or the system administrator. Okay, so let's get started. And by introducing the Click platform, and I promise you I'll only spend a few seconds in here. So if you're talking about data platforms, we have many data platforms, but usually they do one of these blocks, maybe they do 2 of these blocks. So we have data platforms that we can use it to prepare data, transform data, store data. We have others that is basically visualizations, just pretty KPIs, pretty charts. We have others for machine learning. So we have different roles, different types of technology in each platform. Click is the only one that is end-to-end. Gets your data, prepares your data, gives you a few different options to do that, lays your data, and at the end, it communicates your data to actually insights, to actually outcomes. I'm not presenting the whole platform here today. What I'm presenting are these 2 blue boxes on the right, analytics, and the AI piece. So we're focusing on these 2 pieces. Now, I promise that I will only spend a few seconds. So, and because there's so much to present, we're splitting this presentation into 2 separate use cases, and I'll let you know when I'm starting a new use case. One use case is the HR employee retention. So I'll be wearing the green hat. I'll be the HR analyst, and we got data from a company that actually has a problem, and we'll use analytics to understand the problem, understand the symptoms, and then understand what we need to do in order to fix the problem. Then we'll go to a second use case. So we're using publicly available data from the VA's office, and it's a call center use case. So that's where I'll be wearing my black British police officer hat, and so that will be a separate use case. Okay. And again, if you have questions, we have a Q&A session at the end, but if you have questions, keep them coming and we'll find the right time to answer them. So let's get started with the first use case. So we're working with data from a company, HR data from a company, and this company is having a very critical issue. They're losing a lot of their talents. So they're having they don't even know exactly how much, they don't know exactly what is the cause. There is a lot of fingers being pointed. They try different things. They spend a lot of money raising people's salary, did not fix the problem. They fire people, hire people, and it did not seem to actually fix the problem. So they came to data analytics to actually have a better tool to make decision, a more like a scientific, data-driven approach to solve problems. I'll be mentioning a couple terms here. So one most important is machine learning, ML. So machine learning is a field of artificial intelligence, and it's basically a way that we can provide data from the past. So that's this tool called machine learning. We'll learn from whatever happened in the past. We'll understand the relationship within that data to then be able to make predictions to the future and understand what actually is causing a particular outcome. So that's our use case of today. So let's get started. So this is the data that we collected from this company. So it's not a small company. They have almost 10,000 employees. And we have some HR data here, like how many were promoted in the last X number of months, how many were not promoted, what is the average satisfaction, that's how happy the customers are with the company, and then how many hours they work per month in the company. They actually work a lot. That's the average, 184, almost 185 hours per month. That's a lot, and they have 10 different departments. Now, on this table here, we split it like their retention data. So basically we have one column, one variable called left. And those are the employees who left the company. So basically this is like historical data that I'm analyzing. So the employees who left the company in the last 12 months, we focus on the last year, and employees who did not leave. And then comparing those, I can see that almost like 29.2% of the employees left the company, which is pretty big. It's a pretty big number. And then I can see the satisfaction and everything else, and I can analyze the data. However, there was one particular number that let me zoom out here, because I think, okay, that's a better visualization. There was one particular number that I was really worried about, is the review. Average review is the opposite of satisfaction, is how the managers review the employee performance, and the peers also review how it's to work with that person. And basically there's a score from 0 to 100%. So if I look at here, maybe it's a little bit small, so let me read it to you. People who stay in the company, average review is 63%. And then employees who left the company, employees who stay in the company is 63%, employees who left the company is 69%. So it looks like, apparently, that we're not only losing a lot of employees, we're losing the best employees, because 69% is a better review than 63. However, well, maybe 69 and 63, that's a small difference. Maybe that's not significant. Maybe it's about the same. Maybe it's just a margin of error. Let me then use science to answer that question. Is this difference big enough, or is just within margin of error? How do I do it? I don't need to know how do I do it. I just need to interpret somebody else did it. By the way, I forgot to wear my analyst hat. Come on, how did I do that? So I'm analyst now. Now I'm actually an analyst. I don't need to know how I did it. What I need to know is someone wearing a different hat put this together using functions that are available in the Click platform. I do not have to pay a dime extra. And then this, I have a hypothesis. My null hypothesis, like the status quo hypothesis, is there's no difference. It's within the margin of error. And I tested, the math says, actually, you reject null hypothesis, meaning this difference is significant. So it is true, your concerns are true. You are not only losing a lot of employees, you're losing the best employees based on the performance review. So that's a problem. So it makes it just even more important to fix the problem. And then we saw other information here, like how many received bonus, how many not. Only 21% of the employees received bonus. Maybe that could be a cause. Salary range, it looks normal. Most employees have a median salary range. A few of them have high, a few of them low, but kind of very similar. So that looks normal for the company this size. And look, the biggest departments are sales, retail, operations, and engineering. Those are the biggest department in terms of number of employees. Great. So first approach this company had was to blame specific departments. Yeah, it's the manager of specific departments. They're not managing people well. People are happy. They're leaving the company. But then when I look here, the percentage of people that left per department, it's pretty much around 30%, which is the overall, it's close to the overall number, 29.2%. So 28, 28, 20, there was one that is lower, finance 26, but pretty much that. And if I look at here, all departments, look at this box. Well, I don't need to understand, what they mean, but what I can tell visually that they look pretty similar to one another. So I don't have any data to support the assumption that the problem is in a specific department. So they already tried to increase like the best employee salary. It didn't help. So what do I do? Less than bring machine learning, let's bring AI to analyze the data from the past and make predictions to the future and understand what is going on. So that's what we did. So if I look at this table right here, so these are predictions that the model made. They're very accurate. Accuracy here is over 80%, so very accurate. This is predictions that I can trust. And basically for every single employee, and I remove their name, I just put like an ID and number to identify each one for privacy reasons. And basically that's the prediction if the employee will leave the company in the next 12 months or not. So I use machine learning for that. And then you say, well, then you got a lot of people with this hat here that work like they probably wrote like thousands lines of code to make all of this happen. Actually, no. Let me bring back this. We actually use Click-AutoML, and I will show you Click-AutoML in a few minutes. So we use Click-AutoML to provide historical data, to provide the data from the past, what happened, and then AutoML learn from the data. Machine learning is a machine that learn. Great. And then it gave me back the prediction. Is this employee predicted to leave the company or not? Yes, no, simple prediction. But also the probability of that thing happening. Like this employee, for example, from the logistics department that works 189 hours on average per month. And then that's the average review, 68%. It's good, we can consider. But 44% satisfaction, so below 50, so more unhappy than happy. So that might explain why this employee is leaving. So with the 62% of probability of leaving, and this one here, 61%, this one 50. I can sort by the probability, so I can see, look at this. A lot of employees with 99.9% probability. And if I look at these ones, there's a few that caught my attention. Look at this one. This is an employee working in marketing, 91% review. So performance reviews is an amazing employee. Works 177 hours per month. Satisfaction, 26%, pretty low. So that makes sense why this employee is leaving. So maybe I can focus on that employee. All right. So we can come back to this later. So great. But how about if ClickAutoML only gave me that, the prediction and the probability? What do I do about it? Well, I can then bring that employee to my office and we can have a conversation, and maybe the employee will share why they're leaving. Well, there's a problem with that. So a lot of people don't feel safe to share because maybe you're the problem and they don't feel safe to share with you. Or maybe they don't feel safe at all as sharing anything. Or sometimes they don't even know exactly what they're leaving, which is a harder problem. So a lot of machine learning, they stop at that process. They only give you a prediction and a probability. But ClickAutoML also gives you the explanation because you need transparency, especially there's a lot of regulation in AI, and most of them say if you're making decisions using AI, you need an explanation. So Click gives me this chart here with this blue chart here with the explanation. We call that feature importance. It's just a fancy name for like the explanation of the prediction. So the number one factor that is helping the model to predict this outcome, if employees are leaving or not, is how many hours they work per month, which kind of makes sense because people here work a lot. And then the review is number two, which, I mean, empirically, I can think it kind of makes sense because you're only leaving, I mean, disconsidering the case where like you won the lottery or retiring, if you're leaving to work somewhere else, you're only leaving if you have another job offer. So the chance of you having another job offer is higher if you have a better review, because it means that you're a better employee. And, you know, sometimes that comes with other qualities as well. So you might have other job offers. So that makes sense to be in the top list. And then number three is satisfaction, which again makes sense. If you're not happy, there's more likely that you leave the company. Okay, so that makes sense. Those are the top three. However, how much they influence, is that the same for our employees? Maybe there's one employee that's not happy with something, but another employee is not happy with something else. So there are a lot of tools there. This is all they provide. The explanation for the entire model, in this case, for the entire company. But Click said, okay, no, this is not enough. I want to go another step further and provide that information, the explanation, but for every single row, meaning for every single employee. So that's what we do here. So this is the same chart, but now instead of showing the summary for the whole company, we're breaking down for every single employee. All the numbers in red, so each dot here, each bubble, represents the intersection between one employee and one metric, one column. Average hours per month, review, satisfaction, promoted, etc. So the numbers in red, meaning that number, specifically for that employee, it's reducing the chance of the employee leaving. The ones in blue are positive, meaning those numbers are increasing the chance of your employee leaving. So if I pick one employee, let's pick this one for marketing, for example. So if I select one employee, then I'll see, well, the review is number one. So the review that employee received which is 91%, is increasing the chance of this employee leaving. Well, yeah, probably. This employee probably has a lot of offers from other companies. And then average hours per month now is number 2 for that particular employee. You see how it's different for one employee because each person is different. So for that employee, average hours per month, which 177. Yeah. And then satisfaction is number 3. So maybe because those are driving the satisfaction. So satisfaction is number 3. So they are increasing. Now, but look at here, projects. How many projects that employee works in a month? It's decreasing the chance. So maybe it gives me ideas. How can I fix this? If the employee is promoted or not is also decreasing. That fact is actually good because decrease the chance of the employee leaving and so on. Everything else doesn't matter much. But this one here, I know the review is what is the biggest one, which I cannot make anything about it because I cannot just do a worse review or better review. Review, it is what it is. But then I have other variables that I can work with. Then that gives me the tools to understand employee by employee. And because, let me go back to the entire company view again. And because Click AutoML gives me that explanation information row by row, I can do whatever I want with that. I can slice and dice and aggregate and show in any type of graph or visualization. For example, let's focus on the number 1 metric, average hours per month. So if I expand this graph here so we can have a better view. So what does it mean average hours per month is the number 1 factor? Overall, I mean, there's one employee, like an employee was the review, but overall is the number 1 factor. What does it mean? Does it mean that people are working too many hours? How much is too many? What is going on? So then look at this graph. Each one of these little bubbles represent 1 employee. Look at the shape. So the shape will show me the trends, what's going on in the company. So as I add more hours to those employees, more hours per month, like add more work for them to do, look at how the curve is going up, meaning I'm increasing the chance of this employee leaving because I'm just giving more work, more work, more work. Great, but that is not always true because, yeah, it's kind of obvious. I don't need AutoML for that. However, until we reach a certain turning point, which is around 187 hours, once I reach that point, then the trend goes down. Then if I add more hours, then I'm basically reducing the chance of my employees leaving. So what I'm saying is, well, for those employees right here, I just give them more hours and maybe turn them into slaves and explore them. Of course, that's not what I'm saying. This is one variable, then I combine with other variables to understand. Maybe it's because those employees, they're working a lot because maybe the job role is not many offers, maybe their reviews are not as good. I don't know what it is, but I have this data point, I can combine 2 other data points. And now I have data to help me make my decision. Very good. Now again, you're probably thinking, yeah, this is pretty, but however, I bet you spend a lot of money, months of like an army of developers or data scientists developing models behind the scenes. Well, now it's the normal me. Let me show this is not what's going on. Let me wear now I'm the data scientist hat, and let me show what actually happens behind the scenes. So let me open the AutoML module that runs all of these behind the scenes. Very good. So this is AutoML. Don't worry, I'm not going to demo the AutoML itself. I just want to show you a little bit of what's going on. So basically, I will provide my data that I want to be studied for the AutoML, and the AutoML will study the data for me. So let me show you something. I provide the data, and when you provide data to machine learning, it's not just give the data to this algorithm, the algorithm will learn from it, and it'll give you the results. It's not how this works. Before that, you need to prepare the data. So you need to do things like imputation of nodes, encoding categorical features, feature scaling, automatic. You have a bunch of tasks that you need to do. But brown hat Igor or data scientist Igor, I don't understand what this means. You don't need to. I mean, if you want, there's documentation, but you don't need to. Because AutoML knows what these are, and AutoML is the one actually doing the work for you. So you can enjoy a drink, you could do other things, or you can spend more time doing the analytics. You can spend more time wearing the green hat than the brown hat. So Click AutoML does all of that. Why am I showing this? Well, these are tasks that will actually, outside of these two, will require data scientists. They are proficient in R or Python, writing code to perform each one of these tasks. And that's just the pre-processing. That's before the machine learning. Then, what is the best algorithm for my problem? I don't know. There's many options. You only know once you run through different ones, a bunch of them, and then you test them, and then you measure the accuracy, and then you compare the accuracy, and then you select a model. Every single one of these steps that I mentioned is programming. So things like you want to run this against a logistic regression, against a random forest, against an XGBoost, lasso regression, Lastic, Gaussian. So there's a bunch of different algorithms. Again, do I need to understand any of these? No. You don't need to understand any of this. Click AutoML, understand this, and will do it for you. I don't need to understand how telephones work to use a telephone. It's the same analogy. I'm not only showing you that each one of these requires programming if you're not using AutoML, but because I'm using AutoML, it's all performed on the back end. And then AutoML does all of that, measure the accuracy of all of these modules, and then it shows me, I can come here, for example, to have a better, little bit more detail. So it runs all of the algorithms and then have in this case, using this F1 score, no worries, we don't need to understand what it is. Measures how good each model is in doing predictions, and then finds which one it thinks it's the best one, recommends that one, that's the trophy one. And if you like it, you have all of the visualization here as the brown hat person, like the person running this behind the scenes. You see, oh, that's my true positive rate, my true negative rate, that's my ROC curve. But then you analyze and say, okay, I like this. This is good. So then you deploy to production, meaning now I'm putting this in production, so then it's available for the green hats to use. So pretty simple. All right. So that is the AutoML. Let me come back to the green hat, which is the hat when I'm wearing most of the time here. Great. Now I understand how I can use this to actually drive my business better. In that case, to reduce churn of employees, to increase retention of employees. But AutoML does not stop that. So AutoML is available when it becomes like a resource, when you deploy, it becomes a resource that I can use. I can use in many multiple ways. Like right here in this table, the way I'm using is, let's say I'm refreshing my data every day, maybe every hour. Every time I do it, I submit the data to AutoML, my employee data. AutoML takes that data, makes the prediction, and returns back the prediction, the probability, and the explanation. Great. So I'm doing like a bunch of records at once. That's one option. Great, most common. However, I can also do one at a time. So this is one example. I am doing one record at a time, and I can interacting with AutoML real time, live. So let's take a look at this. So I have an employee that is predicted to leave the company, employee in the support department, that has a medium salary, working in 4 projects. That employee is in the company for 6 years. Review is 75%, which is a pretty good review. Satisfaction 45, bad, but not terrible. close to 50. And that employee works 180 hours per month, never received a bonus, was not promoted, not never, in the last 12 months, did not receive a bonus, was not promoted in the last 12 months. Great, so that's this employee. But I like this employee, 75%, I don't want to lose this employee. So my first reaction is, well, let me just give this employee more money. People, of course, are motivated by money. And then, well, it worked. Look at this. The probability of leaving this employee now dropped to 49.3%. The employee is no longer leaving. Great. Hold on. 49.3 is pretty close to 50, which is the threshold here. So yeah, this employee will not leave in the next 12 months because you give the employee more money. So give a little extra motivation. Of course, it works, but the probability is too high. So turns out that maybe, and actually there's a high probability of that, after a few months, maybe after 6 months, maybe after a year, that employee, that the actual root cause of the problem will still exist. And that employee will then leave. And they say, oh, it doesn't make any sense. The model told me that the employee will not leave and the employee left anyway, just took longer. Well, don't use just AI, use human intelligence with AI, then we have hybrid intelligence. So my human intelligence says, well, this is still high. So let's see if we can do something better. So let's keep the salary for now. And let's analyze the rest of the data. So look at this. The review of the employee is 75%. I'm comparing to the rest of the employees population, that's above the average, which will be the peak of this curve. Review is not something I can change. It's basically, it's an independent process. Managers and peers review the employee performance. So nothing I can do here. The satisfaction, I cannot do manually, but I can maybe try to do something that I would drive the satisfaction. It's low, but it's kind of close to the average. So it's not my first concern right here. Of course, I want all the employees to be happy, but there might be a cause that's driving the satisfaction low. Average hours per month, it looks pretty high, but it's actually lower than most of employees. So, and then when I look average tenure, like how many years the employee works in the company, I cannot change that. Every year pass 1 year at a time each year. I would love to be celebrating my 21st birthday, but I have 20 plus more than that. So a year is something we cannot yet change. But look at this, projects. So that employee is working per month, an average of 4 projects per month. But if I look here, most of my employees work from 2 to 3. 4 is in the far end of that. So basically, I'm giving a lot of work to this employee. So let's try bringing, I cannot make like 2.5 projects because there's no half project. Let's try to bring it to maybe 2. Let's say, look at that. I'll bring in that and say, now you're working half the projects. We'll promote you because then you train and manage other people do their work. And great, now we're talking. And I can even give you a raise if I want to give you a raise. But if I never change this, then the outcome will never actually really change. So now we're talking. Now this makes sense. Now this employee that's in the company for 6 years, maybe I'm thinking about 10 years, maybe more, because I fixed the root of the problem. So this is how, and every time I click this, I'm sending this data to AutoML. AutoML is calculating all of that and bringing back. Look how much it takes. It's less than a second. That's how fast AutoML is. So great. So then we can, I use this in HR example. We can use that for healthcare. We can use this for finance. We can use this to fundraising. You can use this to any industry. If you have a problem, that we can then structure that problem in a way that we have a question that we answer. What is my revenue? Am I retaining this customer or not? And so we can use this for like any market. Okay. So this is our first use case. But before we go into the next use case, let me take out my hat. It's time for our second question. What challenges are you facing with call center efficiency or employment experience that you like to address with AI or machine learning? So you got the poll popped up in your screen, so feel free to answer those. Okay, so we'll present this question before the second use case because we want people to answer this before we actually presented the next use case, which is this. So I took public available documents from the VA's website. Basically, something is available on the public website. We took those documents and we used those documents in this next use case. So that's a separate use case, different than the one I presented before. And we're doing a support or actually a call center example here. But there was a few concepts that I would like to highlight before we begin. First is, the first use case is like the classic analytics dashboarding use case. So we have what we call structured data. What is it? Structured data? It's data that is in a given structure, like in a table. So data that comes from databases, Excel files, CSV, things that are structured either in a hierarchical way or in like rows and columns. Those are structured data. Now what I have here is unstructured. What is unstructured data? Documents, like text files, PDF, Word documents, PowerPoint files, web pages, audio, video, emails, Twitters. This is unstructured data. So they're not in like row, column base, but there's a lot of knowledge. So you see I have a lot of books on the back end. They're not structured, but there's a lot of knowledge there. But however, how do I find information in this kind of data? So maybe you need to search. So search is a great tool. However, search, you need to know exactly what words, sequence of words. So we know when you try to search the content in the document, how it's not straightforward. Maybe there's a different word, and you can actually ask questions. It's just a search what it is and then read it. So that's unstructured. The example that I'm giving, like I would love to ask a question, retrieve information from those unstructured data, from documents, and then get my question answered. This is a concept called RAG, Retrieval-Augmented Generation. And you receive like a slide deck with all of these so you can read it through. But there's some terms also, if you want to know more, you can search these terms. Another one is LLM. LLM is large language module. So when you're talking about ChatGPT, for example, Google Gemini, all of those, these are examples of large language modules. So is a type of AI designed for language, but they are trained in millions or billions of parameters. So basically, they know a lot. It's like a person who read a lot of books. So these are the terms that are related to this. But again, I'll make this as simple as possible. So I will start by wearing my call center analyst hat. Okay, so then let's go to, wait, sorry, I'm so sorry. I really need to take this call. I'm sorry. Let me take this call. 1 second. Yes. Hey, sir. Oh, okay. Yeah, you're a veteran. So yeah, you called the right place. Yeah, this is Veterans Affairs call center. So you want to know how you apply for benefits? Okay, yeah, I can help you with that. And oh, you're also having problem with the mortgage. Well, okay, I need to do a little research, but definitely I can help you, sir. So do you have your veterans ID card? Oh, yeah, no, yeah. You need to apply for one. Oh, yeah, I can get you information how to get a veterans ID card. Okay. All right. So Give me a few moments. I'll get this information and I'll call you right back. All right? Thank you, sir. Okay, that actually was. So now I'm wearing this hat. As soon as I put the hat, I started receiving calls. If you work in call centers, you know, that's pretty much what happens. And there's always a lot of demand. And I got a few questions from veterans that I would love to help. But I don't have this information handy, so I need to search in specific documents, you know, documentation, different systems, SharePoint, whatever it is. I need to search for that. Actually, people told me that I now have this new tool that I can interface with. This is called Click Answers. It's the LLM, is kind of the ChatGPT inside the Click platform that is trained on my unstructured data. In other words, it's trained on my documents. So I got these, not me, the brown hat person, got these documents from the VA's website, and then the Click Answers was trained on those documents. So let's try to answer the customer questions. So let's start. I copy and paste the questions here so we don't need to waste time typing. So how do I apply for veteran benefits? So let's see. So it's a question. It doesn't have to be those words in the document. It's just a question. So it's an AI, so we'll understand what I mean and we'll find information. Then we got an answer. There are several ways to apply for veteran benefits, for the education benefits, etc. And then it gives me like the answer that I want, and I can interact with and I ask for more details or clarify some specific topics, etc. So instead of looking for a bunch of documents, I can have a normal conversation with all my library of documents, all the knowledge inside it, and get the answer. So that's, in terms of efficient, it's amazing. For educational purposes, actually we run this internally at IPC. It's uploaded in a Click Answer, so people can look at it, ask questions. So they'll have these as an answer, the answer what they're looking for, and they even know where this came from. Now, I got this answer, but why not simply use like ChatGPT? I can use ChatGPT, and then I'll get an answer. Well, ChatGPT, and when I tell this to people, people get really surprised and think that I'm actually lying. ChatGPT was not designed to answer questions. Wait, what? Of course it was. I asked questions to ChatGPT, and ChatGPT answered the questions. No, it was not. ChatGPT is designed to complete your sentences with the most probable sentence. So if I start typing something and ask you complete, you complete that. Turns out that coincidentally, actually or not, the most probable way to complete a question is with an answer. And well, isn't the same? No, it's not, because there's no fact check. So if I ask a question to ChatGPT does not know the answer, it will create fiction. And it's so well written that will look like it's actually the real answer. And if you ask for references, it will give you sometimes fake references if it cannot find the true references. So Click Answers, on the other hand, is not designed to have a conversation with you. I recommend therapy for that, or friends. Therapy first, friends second. Click Answers is designed to answer your questions based on the knowledge it was trained. And how do I know this is more effective than ChatGPT? Well, it gives you the answer, but also gives you the source. So you don't need to trust this. You can check the source if you want. So I found 3 sources, gave me the sources here. If I have the proper right, I can even click this button and download the PDF. It's a PDF file. So I can download the PDF file and I can read it on my own. It shows me exactly where is the information, the reference here, but I can download the whole document if I want to, if I'm more curious about it. And I've done a lot of experiences. I even like created a book like programming books and taught click answers to program the kind of stuff. It's pretty useful. Okay, so now we had another question from our veteran, which is actually waiting. I need to call back. And so what should I do if I'm having trouble paying my mortgage? Let's see. Ask the question, and then click answers will give me if you're having trouble making your mortgage payments, you should contact your loan servicer, then give information, and gives me the source to that information. Same idea. So that's one of the beauties of click answers. It's trained on your data. It's all protected. So it's in your, in this case, it's in the cloud, it's in your infrastructure. Let's say you have a SharePoint, that's part of the data. SharePoint is your SharePoint. So it's different than, for example, the ChatGPT. You actually need to upload the documents to the infrastructure if you want to use documents to answer questions, or just trust. They have that knowledge in their knowledge base and they trust the answer, which is not very much recommended. Now let's try the last question. How do I get a veteran's ID card? No, you know what's great about also better than this click answers is click answers does not hallucinate. Hallucinate is when the AI does not know the answer of something, and then it's just make things up, creates fiction, just because it doesn't tell you I don't know, it just creates fiction. Not click answers. How do I get veterans ID card? And when look at this, I'm sorry, I don't have any information to answer that question, but I could help with something else. That looks bad, but it's actually amazing. Because if he does not know something, I want to know he does not know. Don't give me false information. Just tell me, I don't know. So I'll handle that. And why he doesn't know? This is public data, publicly available data. So why it does not look into the internet is because it was designed not to. It was designed to only answer questions based on the knowledge you provided. And that is great because you control the knowledge that he has. So employees will not be able to use this to get like drinks recipe or recommendation for the next vacation, unless you want them to and you upload those documents. So this is amazing. However, I really need this answer. So let me give a feedback. Let me do a thumbs down. Let's say it was unhelpful. And let's say I really need this answer. And let's submit this review. Pretty good. Now, what happens behind the scenes? Well, when I say behind the scenes, that means a different hat. Actually, yeah, that means a different hat. So, behind the scenes, Click Answers has basically two separate tools. One is the chatbot that we see here. We call the assistant. So if I open the assistant, that's the assistant. So my assistant was trained on this thing here. So that's the data, that's the knowledge that it has. So now that I'm wearing this hat, the brown hat, I can see things behind the scenes. So I can go to review and see, oh, someone made a review, says that was unhelpful. The question was, I'm sorry, I don't have information to answer this question. And the comment was, I really need this answer. The question was, how do I apply for vet? Actually, yeah, I think that was right. Yeah. So great. So I got this because I'm wearing this. So I got this review. And he said, oh, I really need this answer. Very good. Because I'm wearing this, I'm in the assistant. Now, where does knowledge come from? So let me go back here. And now I said there's two different tools. One is the assistant, the actual chatbot. The second is the knowledge base, the knowledge that the chatbot has. So this knowledge we have here, I call it the Veterans Affairs knowledge base. So basically, there are 28 documents, total of 194 pages. If I expand it, I see these are all of the documents. So I need that information. So I call back support agent and said, okay, great. I checked the knowledge base. There is no document or any data that talks about applying for like veteran's ID card or anything like that. Then it comes back to me, the poor call center agent. And then I say, well, but I'm wearing this hat, so that means that I have great skills for investigation. So I think I need to work kind of like a detective and investigate this. So I heard that I've actually found and heard that we have this information on YouTube. So I can say, well, let me take a look at that. I said unstructured data is also video audio. So look at this. These are some of the videos we took as a sample from the VA's YouTube channel. And this is one, let me get, we have how to get a veteran's ID card. So let me select that one. So we got that. We used some AI to extract the transcripts or the text spoken on that. These are the most common words. And I can even play the video. So that's the actual video. I can read it through it. Great. However, I don't want to like watch videos to answer that question. I want to be able to get these unstructured data, this data from the video or the transcription from the video, and then feed that into the assistant, which is here. Feed that to the system. So how do I do that? Well, let's create a new knowledge base, but I don't know how to create a new knowledge base. I don't know how to do it. Well, I guess I need a different hat. Let's bring back the brown hat and let's do it. So let me come back here and let me go create a knowledge base. And I'll call this VA video knowledge. All right, so I can get this information from connection. I can connect to other data sources and get where my documents, SharePoint, etc. are. I can upload files I can get from my catalog. I already have those in my catalog. I just saw in the app. So let me come here. Let me find, I know those transcripts are text files. So I'll select all. I click select here. Now I have those. Am I ready? No. You only loaded the documents. You have 0 pages, means it's like you bought the books, but now you have to read the books. So ask the knowledge base to learn from this, which is called indexing. So then we'll be indexing this. In the meantime, let's pause for the third and last question. Then I'll come back to this and wrap up. So the third question is, what metrics or outcomes will be most valuable to you when leveraging AI or machine learning for call center, HR improvements, or other areas? So these are the options. You now just saw the question be popped up to you. And so in processing will be done in a few minutes. So once that's done, I can come to my assistant and I can add that knowledge base. So I can come here and add this knowledge base. Now, my assistant has 2 knowledge bases. You know what's great? I can secure them differently. So depending on what hat or what person is using, it will have one information, not the other. So I have 100% control of the access, of the security of the data. So I know this people here can have this kind of information, but not that one, and these people can have this information, not access to that one. It's like you have these very detailed control in your chatbot, which is like, it gives you so much security, power, and control. Now, indexing is done, 17 pages. So you can go back to the application. We can go back to that. And for that, I'll bring back my hat of the call center agent, and I'll ask that same question again. And then I'll ask the question. And it says to obtain a veteran's ID card. So now I got an answer because now I added that knowledge. And I did not write a single line of code. And there's a lot of complexity things going on the back end, but because I'm not wearing my brown hat, I'm not going over that. Now I can come back, call my customer, and then give it the answers. So that's what I had today. Now it's call back to you for Q&A, and hope you enjoy this. And now, no hats.
Absolutely. And thank you so much, Igor. We really appreciate you speaking with us today. We can go ahead and start the Q&A. If anyone has any questions, to please use the pod at the bottom of your screen. It looks like we have one question that might be all we have time for at the top of the hour. It says, what types of data are needed to train the models effectively for use in call centers and HR? And how would companies ensure data privacy and compliance?
Those are great questions. So starting with the first, what kind of data? So if you're talking about the second use case, any unstructured data. So any documents, web, HTML files, text documents, SharePoint, anything that is in a format of text, some form of text, we can fit into it. And on the analytics part, which was the first use case, like basically any data. I never saw a data that I could not bring and work with and put in the tool. In terms of data privacy, Click has, and if you go to click.com, there's a part about the security there. If you want more details, but Click has the most important certificates in terms of security. All it's HIPAA compliant, all of the ISOs and all of those security certifications. So it's all encrypted, and it runs on top of AWS, which is the most secure cloud platform. And for government agencies, they have specific government cloud tenants. So it's even there's like extra layers of security. There's extra security certifications for government as well. So and so on the platform side, you save. What you need to worry about is how to configure and how to train your people to actually use the information in an ethical and responsible way.
Gotcha. Thank you so much for your insight and answering those questions for us. I do believe that is everything we have time for today. So I would like to go ahead and thank our participants as well as Igor for being with us today. We hope the information you received during this webinar has been helpful.